In the figure, each side of square ABCD has length 1, the length of line segment CE is 1, and the length of line segment BE is equal to the length of line segment DE. What is the area of the triangular region BCE? So this question looks like it's going to be hard. The first step, though, is just drawing a good diagram. And then also labeling it well. So what do I know? So I know ABCD here is a square, and each side has a length of 1. CE is also equal to 1. BE is equal to DE, and so I can just note that like this. So now I don't have a I don't have a line connecting B to D, so I don't have a full triangle here, but I can draw an imaginary one. And this line also happens to be the diagonal of the square. And so now I have this new triangle BED, which is isosceles, because BE is equal to DE. And so with that, let's start thinking about how can we find BCE. We don't know this angle here, so we can't do something like 1/2 base times height. We don't. So, but if I can draw another imaginary line here, so I'm going to make a new point that I'll call F. We'll say F is the center of the square. So if I have this new point here, then I draw a line connecting F to C. Where do I know? If I have a square and I have two diagonals of a square, those diagonals should be perpendicular bisectors of each other, which means this angle here is 90 degrees. And so if I can look at this segment here, FC, that is just half of a diagonal. So what is the length of my diagonal? Well, this is a right triangle here, and it should be a 45, 45, 90 right triangle, because this side has length 1, this side has length 1 as well, and so that should be in the ratio of 1 to 1 to rad 2. So my whole diagonal is equal to rad 2, and so this segment here, FC, should be half a diagonal. So that should be rad 2 over 2. So now, based on this, and so this segment here, BF, this should be also equal to rad 2 over 2, because it's half of a diagonal. So based on this, I can now, if I can find the area of this triangle BFE, which is a right triangle, so that shouldn't be that hard to do, and then subtract out this triangle here, so the portion of that triangle that's within my square, so that's BFC, I should be left with BCE, which is the thing that they're asking us to solve for. So let's see if I can do that. So again, so BFE is a right triangle, so I can do it 1/2 base times height, where BF is my base, and this line here from E to F is my height. So 1/2. And then so BF, it's half of a diagonal, so rad 2 over 2. Times my height, and so my height is made up of EC plus this half a diagonal that I extended it by, so that is going to be rad 2 over 2 plus 1. And then we'll find this in a second. Let's simplify this guy first. So 1/2 times rad 2 over 2 should just be rad 2 over 4 times rad 2 over 2 plus 1. So if I want to combine within my parentheses, this is rad 2 over 4 times rad 2 over 2 plus 2 over 2. So I can just make this 2 over 2. So that is rad 2 plus 2 all over 2. And this leaves me here with something over 8. So rad 2 times rad 2 is just 2. So 2 plus 2 rad 2 all over 8. And then I can factor out a 2 up top. So that's 2 times 1 plus rad 2 all over 8, which is just 1 plus rad 2 all over 4. Okay, so that is the area for my big triangle BFE. So now I need to subtract out this triangle BFC, so the portion of that big triangle that's within the square. And so my diagonals, which are perpendicular bisectors, they should split the square into 4 equal triangles. So the area of this triangle here should just be 1/4 the area of the square as a whole. What is the area of the entire square? So if each side is 1, the area of the square is 1. So the area of the triangle BFC should just be 1/4. And now, thankfully, these are set up so they already have a common denominator. And so I'm left with what? So 1 plus rad 2 minus 1 is just going to leave me with rad 2 all over 4. And that is answer choice B, it looks like.